This is Chapter 7 on C pointers. So in this chapter, we discuss one of the most powerful features of the C programming language called the pointer. Pointers allow us to simulate pass by reference and to pass functions between functions and to create dynamic data structures, meaning data structures that can grow or shrink in size at execution time. And some of those data structures you may have heard of. Some examples are linked lists, queues, stacks, trees. Later on in chapter 10, we'll use these same pointers together with structures. And in chapter 12, we learn about another concept called dynamic memory management, which also uses pointers. So what is a pointer? A pointer is a special type of variable. It's a variable whose value is an address in memory, a location in memory. So before I proceed, let me just give you a parallel, another way to think of what a memory address is. We've already seen what memory addresses kind of look like. You're already familiar with the format converter %p. The P, remember, at that time when I introduced you to it, stands for pointer. That's the same pointer that we're studying about now in this chapter. A pointer is, you can think of that as, so a memory address, you can think of that kind of like a GPS coordinate. When you use some map application and you drop a pin on a map, that pin represents a GPS coordinate, something in the form of 37 degrees, 40 minutes, 36 seconds north, and then that is followed by another coordinate, something like, I'm just making numbers up here, something maybe like 24 degrees, 30 minutes, 22 seconds west. So together, these two numbers represent a location on the globe. A memory address is kind of the same way in that it specifies a precise location, a precise place in the memory of your computer. And such an address, such a location, such a location can be stored or is stored in pointers. Now, all the variables that we have seen so far simply contain some kind of value, depending on what type of variable we're dealing with. If it's a character variable, it stores a single letter or other type of character. If it's an integer variable, it stores some kind of whole number, positive, negative. If it's a floating point or double precision floating point variable, it stores a positive or negative fractional number. But a pointer is a kind of address, is a kind of variable that stores an address of some other variable, or actually sometimes also of something else, of a data structure. We'll get to data structures later, but for the moment you can think of it as the address of some variable that exists somewhere else in your computer's memory. So in that sense, you can use a pointer to indirectly access a variable. Accessing the value of a variable through a pointer is called indirection. And you can visualize that kind of like this. If you have a variable called count and it stores the number 7, you can think of that as looking like this. It's kind of what the view of a variable that we're familiar with. And if you access this value 7 over here and you access it by simply using the name of the variable, which is what we have been doing so far, this is called directly referencing the value of variable count. But if you want to reference it indirectly, what you do for that is you first create one of these pointer variables. Maybe this one over here, we will call it count PTR. PTR is short for pointer. So I'll read that as pointer from now on. So we could also create a pointer called count pointer, and its value will be the address of variable count. And so indirectly accessing the value of count would be accessing it through the count pointer. Let's first look at how we declare pointers. You can easily distinguish a pointer variable from any other regular variable by this asterisk that precedes the name of a pointer variable. So in this statement over here, we are declaring an integer called count and a pointer called count pointer. Not only that, pointer variables can be of different types. Depending on what type of variable they're pointing to. So this one over here in our example, count pointer, points to variable count, which is of type integer. So count pointer then is, we say count pointer is a pointer to an int, to an integer. Or you could say count pointer points to an object of type integer. So not all pointers are alike. We distinguish between them based on the type of object or the type of variable that they're pointing to. Count, however, over here remains a regular variable of type int. Now, you may, initially at least, you may be confused looking at this statement over here and think that maybe this statement represents two pointer variables, one called count, the other one called count pointer. That is not the case. The asterisk that we have over there only applies to count pointer. Pointers can be defined to point to any type of object. Now, at this point, with us learning C, you don't even know yet what an object is. An object has a very specific meaning, and we'll get to that at the very end of this course, hopefully, when I introduce you to object-oriented programming. But so far, that's outside the scope of this course. Now, to prevent any kind of ambiguity when we're declaring pointers and non-pointer variables, we shouldn't put them in the same statement in the same line. We should keep them on separate lines, perhaps. So as an example, if you actually wanted to declare two pointers of two integer pointers, the correct way to do that would be something like this. Int asterisk x pointer, comma, and then comes the second pointer, asterisk again, y pointer. So you have to put the asterisk in front of each pointer variable that you're declaring, not just the first one. Another good programming practice is to come up with a string of some kind of notation that you're going to stick to in order to easily distinguish pointer variables from all other types of variables. And in this chapter over here, what we're doing is we will be using the letters PTR in the name of every pointer variable to make them stand out from other variables. Now, whenever you declare and define a pointer variable, you should initialize it. If you don't, you have no idea to what address it is starting out with, and that pointer could really be pointing to absolutely any place in memory. So whenever declaring pointers, never forget to initialize them to something. Now, if at the time that you declaring a pointer, you do not have any variable to point it at yet, at the very least what you should do is you should initialize it to null or 0. Now, you've already seen null before. Null is basically all bits set to 0. It means that in this context, it means if you set the value of a pointer variable to null, it means it's pointing to nothing. Null is a symbolic constant. And it exists somewhere in the standard definition header file. Now, you could, when you are declaring a new pointer, you could set its value to 0. That'll work. And that's actually the only integer value that you can directly assign to a pointer. But it's usually preferred to set its value to null instead. Both will accomplish the same thing, but please, if you have to initialize a pointer to point to nowhere, use this symbolic constant null instead of 0. If you try to assign any other integer value to a pointer variable, that will not work. So let me just reiterate one last time. Make sure you initialize pointers unless you want to see your program crashing perhaps. Okay, so let's try out a very small and simple example. Together, so when we're working with pointers, we need another operator, the address operator, which you've already seen. That's the ampersand sign. So we'll be using both the asterisk, the pointer, the unary pointer operator, as well as the indirection operator, as well as the address operator in this example. So let's look at these three statements over here. So in the first statement, we are declaring an integer variable y and initializing it to 5. On the next line, we are declaring an integer pointer variable y pointer. Now we haven't initialized it to anything yet. That comes in the next statement. What we want to do is we want to set we want to point y pointer at variable y. And the way to do that is what we see in the third statement. What we're doing is we are setting the value of y pointer equal to the address, that's what the ampersand does, the address of integer variable y. So this is how you properly initialize a pointer. Now I'll also show you how to use a pointer in this example. So this last statement, basically, in this last statement, what we're basically doing is y pointer is, after this statement executes, y pointer is pointing to integer y. So let's look at an example. Let's say this integer y is stored at a location in memory, let's say this address over here, 600,000. And let's say that pointer variable y pointer that we defined is stored at some other location in memory, let's say 500,000. So what will happen in these, what these three statements will do is basically this. Integer y was created over here and initialized to the value 5. Simple enough. We then declared y pointer, and in the third statement we stored the address of y in y pointer. And if you want to add the addresses to this example, it'll look kind of something like this. So we said integer y is at location 600,000 and stores the value 5. After we run the third of the last of those three statements, integer variable pointer variable y pointer itself at location 500,000 will have inside it the address of y, 600,000. Now, we still haven't used the pointer variable to do anything yet. That comes next. Now, to use the pointer variable to access the value of the variable it's pointing at, whose address it contains, we use the indirection operator, that asterisk. It's also called the dereferencing operator. And what it does is, if you put that in front of a pointer variable's name, it returns the value of the object the pointer is pointing at. So in our case, that means if you print out the value of asterisk y pointer, that is basically accessing the value of the variable y pointer whose address is stored in y pointer, which is the variable y. And the value of variable y is 5. So if you run this statement over here, the output that will be printed to screen is 5. Again, please don't dereference a pointer that hasn't been initialized. If you do that, you will end up with a fatal execution or runtime error. And I'll show you a coding example, and in that we'll be using the address and indirection operators together. That's also interesting. We'll basically do three things. We will look at the addresses of the original variable as well as the value stored inside the pointer variable. We'll access the variable value directly and through the pointer. And finally, I'll show you something you can do by using the address and indirection operator together. The thing to see there is that they're both complements of one another. If you apply both to the same term, to the same variable, they kind of cancel each other out. And it doesn't even matter in which order you apply them. And here's a simple piece of code. So we declare integer a, initialize it to 7. We declare an integer pointer variable a pointer, and at the same time we initialize it to the address of integer a. So wherever this variable a is created in memory, that address will now be in a pointer. So we have three printf statements after that. In the first printf statement, we print out the address of the variable a. We've done something like that earlier. And we also simply print out the value stored in a pointer. Now, both those should be the same, correct? After all, a pointer has in it the address of integer a. Then we have the second printf statement. In this one, we first access the value stored in integer a directly, like we've always been doing. So this should print out 7 over here. And then we access the value in a through the pointer variable. And we do that, remember, using the indirection operator, the asterisk. So asterisk a pointer will also let us access the value stored in a. Finally, let's print out the values of ampersand, asterisk, a pointer, and the value of asterisk, ampersand, a pointer. So we switched out the order of the two unary operators over here. Now this one may be a little more difficult to make sense of, but think about what this one might mean. It is the address of the value of variable a. Now, this one may be harder to read in that sense, but I already told you that these two operators, the asterisk and the ampersand, the complements, they kind of, when they appeared right next to each other, applied to the same variable like this, like we're seeing over here, they kind of cancel each other out. So let me show you the kind of output that you can expect from this. The addresses, when you run this on your computer, will be different, of course, every time. But here we go. So the first printf statement. The address of a is this address over here, and the value stored in a pointer will be the same address. The value of a is 7, and the value of asterisk a pointer is also 7. So two different ways to access the value of the same variable a. And finally, the third printf statement. You can see the address that we get over here is the same that we're getting as output in the first printf statement. And you can see the last one over here also gives us the same address again. Whenever we see an operator, whenever we learn of a new operator, we place it in the order of precedence with other operators. And in this case, the indirection and address operators are right here at the top.